Greetings and welcome to our discussion on descriptive statistics. Now, descriptive statistics are something that you're going to want to use in your papers because it provides you with a description, a snapshot of what your data looks like. For instance, what's the range, what's the central tendency area, and those kind of things. So when you think about providing a picture of what your data looks like, it's really important to let your reader know that the data looks like, so that they can get a comparison idea of what maybe the population looks like or where you're starting and those kind of things. So we're going to start with some of the basic tools that you can use in Excel to talk about the descriptive statistics for your specific data set. We'll talk about why are pictures better than data sometimes. We'll take you through the creation process for histogram and polygons. We'll take a look at the data analysis tool pack, and I know we talked about that in class already and showed you how to upload it, but make sure that you get the chance to upload that in your program. We'll talk about skewness and kurtosis functions, as well as the Excel to create and modify charts, and what are some of the different ways of putting charts together, and when do you want to use specific types of charts. So why do we want to use pictures instead of just the numbers themselves? Well, when we can take a look at this data set, and we want to think about one area, which is the central tendency, and another one about how spread out the data is. If you remember back to our discussion on the guy trying to cross the creek, the average depth was 18 inches, but we didn't know what the range of the depth was. Yeah, if it was 18 inches all the way across, a stable 18 inches, great. We don't have to worry about that. But in some cases, you're going to see some range in that, and that's typically what you're going to find in your data as well. So we have one score for describing a grouping of data, again, which is our measures of central tendency. And then we also have a measure of how diverse or spread out the scores are, and that's called our measures of variability. And sometimes, since we know what those numbers look like, again, the measures of central tendency are mean, median, and mode, and then the measures of variability are range, variance, and standard deviation. But when you typically tell somebody that the variance of your data set was 42 and the mean was 57, what does that really show? What are you talking about there? It's tough to try and get an idea of what that looks like. So we're going to talk about how you use illustrations and charts and graphs to show that data. Well, one of the things that you've got to do whenever you're putting together a great chart is these are some of the rules that you want to follow. One is minimize the junk. Don't have so much information in a chart that you just can't get to it, right? We want to make sure that we try and include important data, but if there's something that's not contributing to the point you're trying to make, don't put it in there. Make sure you plan before you start creating. What is it that you want to show? Remember, we talked about the research question being the most important thing for your research project. Well, here, again, you got to know where you're going before you can start putting it together. Say what you mean and mean what you say. Don't start going off on different tangents about the data as well. Label everything. Make sure there's labels for all different kinds of things in there. And if you have too many labels, maybe you need to split it out into two different charts. Make sure that you're only using the chart to communicate one specific idea, right? Don't try and convey what the population of the United States is, along with their salaries, along with how many cars they own, all in one specific chart. Keep it to one idea. Keep it balanced as well. Maintain the scale in the graph. In other words, don't try and spread it out too far. And keep your charts simple. Simple charts are the ones that make the most sense, and people like to read them. If you overwhelm somebody with too much information in a chart, they just quit looking at it. And again, it should convey what you want to say. If somebody looks at the chart, they shouldn't need an explanation to go along with it. Granted, in your papers, I want you to do an explanation, but if I look at a chart, I should be able to figure out what you're trying to say. And then it's up to you to try and interpret and analyze that particular set of data. Frequency distributions. Now, frequency distributions are probably the most basic kind of illustrations that you can do with your data. It's a way of tallying and representing the number of times specific scores occur. And what we do is we put the scores into interval classes or ranges. And typically when we think about creating class intervals, we have a range of 2, 5, 10, or 20 data points inside of each one. 10 to 20 data points can cover an entire range of data, right? And we want to list the class interval with a multiple of the interval. And then the largest interval will go up at the top. Here's an example of a histogram that we're going to draw just using our pencil and a piece of graph paper here. Notice that we've drawn hand-drawn it here, and we have our class interval, right, which is 0 to 4 on that first one. And then we have 5 to 9 on the second, 10 to 14, and so forth, all the way up to 45 to 49, all the way on the right-hand side. Also notice that the midpoint of each one of those bars is identified. We simply add the two numbers up and divide it by 2. So for the first one, you can see that the midpoint is 0 to 4, and 0 plus 4 is 4, divided by 2 is 2. And we do that all the way down through. So we can identify the midpoint of each one of those. Here's an example of what we can do with the tallying. Now, before computers, this was actually what I ended up using for tallying of data points on the various tools that I used to use in the Navy, such as satisfaction with promotion rates and those kind of things. Seems a little bit crude, but it worked great. So each time you see a data point, you would find out which range it falls into, and then you would simply put a mark there. And then you would do that for each one up to 4 times, and then when you came across the 5th time, you put the slash through it. So each 4 marks with a slash would equal 5. And that way you can quickly count up the slashes, and instead of counting up the individual tick lines, and be able to see where the data is going to lie. But histogram Excel will do a histogram for us. And here you can see we have a set of data. This could be anything from ages to speeds on the road or whatever we have. But in this case, we're going to use scores, right? Scores. And feel sorry for that poor person that got a score of 2 on this particular test. But anyway, these are the scores here. And just looking at the data, it's kind of tough to see what it's trying to tell us, right? I mean, we can see we have a high score, it looks like a 47. We have a low score of 2. And then our data is spread out all the way in there. But where is the central data located? It's tough to say. We would hope that 47 minus 2 gives us 45, right? And then divide that by 2 gives us 27.5 plus 2 gives us 29. So we're thinking about maybe about 29 should be around the midpoint of the data. But we don't know for sure. So we're going to have to take a look at this and see. First thing we do is we set up our bins. And notice we have our bins set up over here on the right, 49, 44, 49, 44, and so forth. And we're going to take a look and see how we can use the histogram tool in Excel to set up our histogram. There's a histogram tool, again, in the data analysis dialog box. And what we do is we find out our input range there and our bin range. And then we're going to have it put it into a new worksheet ply. Notice under the output options, it says new worksheet ply. So we have identified our input range of all those data points between cell A2 and cell E11. And the bins that we're going to put it in are G2 to G11. And we're going to have our output range now. We've changed it. Notice here that we had a new worksheet ply. But we don't want to have it do a new worksheet ply. We want to put it in the same sheet that we're already working with. So we're going to put it in cell H1 is going to be where it starts. Also note we have cumulative percentage and a chart output because the boxes are checked at the bottom. So when we put you can see where we have our bin set up, 49, 44, 39, 34, all the way down to 9 and 4. And then we have our bin and the frequency and all the way down to our cumulative percentages. Now, a frequency polygon is basically just a continuous line that represents the frequencies of scores within a class interval. And it simply connects the midpoint of each one of those bars together. And so we can get a little bit better idea of the smoothing out of it. And we can take a look at frequency distributions as well. And we can see that there's 4 different ways that we can take a look at them. We have our average value. We have the variability in the score, and then we're going to talk a little bit about skewness and kurtosis as well. And we've talked about those a little bit already, but let's get into them some more. Here's an example of the different averages, right? This is what we call a family of normal distributions, a family of normal distributions. You can see we have a low score and we have a high score, and within that we can see that each one of these groups, right? These might be 3 different classes given the same test, have different averages. The average for class A, average for class B, and the average for class C. Now these all have the same standard deviation because you can see they're spread out almost exactly the same, and they also all have the same height. So they're all normal distributions, but they have different averages. Now, variability will also tell us a little bit about it. Here you can see that we have a couple of distributions with the same mean but different standard deviations. Distribution A is very high in the peakedness or kurtosis level there. Distribution B has a medium-sized kurtosis there, and distribution C has a lower level of kurtosis of the peakedness. So more of the data in distribution A is clustered around the central area, whereas in distribution C it's spread out more along the lines. Here we get an example of our positive and negative skewness. Notice with distribution A, it says it's positively skewed. Distribution B shows no skewness, and distribution C has negatively skewed. Now, the way you can tell whether a distribution is skewed and which direction it's skewed is the tail. If you look at the tail of distribution A, it goes off to the right. The lumpy area is off to the left. So the tail goes off to the right, to the positive side of the distribution. So that means it's positively skewed. However, on distribution C, you can see that the tail goes off to the left. And here we can see that we have a negatively skewed distribution. Here's our degrees of kurtosis. And again, kurtosis is not a disease that you're going to get, but it's simply the level of peakedness that you're going to see. Now, distribution C has a very, very positive kurtosis coefficient. Distribution A has a very low kurtosis coefficient, and B has no kurtosis at all. It's a normal distribution. So when you get your data from your descriptive statistics box, you have a skewness coefficient value in there. If it's closer to 0, it's going to be closer to a normal distribution. If it's a positive number, it's going to go closer towards distribution C. And if you have a lower skewness coefficient, it's going to be in distribution A. So here's some excellent charts, right? Excellent charts from Excel. Here's an example of how you can create a simple column chart. Notice we have those two data points there, males, how many males there are, and how many females. And we can use our column chart there and simply plug that in, and it'll give us a variety of column charts to select from. So you can pick different types of shapes that you want to use if you want. For the most part, APA just uses the standard rectangle there, but in your reports for other places, if you want to, you can get pretty fancy. In fact, I think in the new Excel chart, you get to pick your type of graph that you want to use. If you wanted to use a picture of a mug, you could put the mug in there, and the mugs would vary in size. I'm pretty sure that that's available in Excel. So you click Chart Type, then you click Finish, and it's really quite easy. Notice off to the right we have a Series 1. That's showing you which series that is. Now when you only have 2 data points like this, you can probably just delete that. But you do want to make sure that you try and put in a title there so you know what males and females, what are we measuring on the males and females here, or is this simply a count of males and females? Here's some additional charts that you can take a look at. Mono cases by season. You can notice that in the wintertime, mono cases go up significantly. And again, we can compare 3 different data points here, School 1, School 2, and School 3. Notice that they also all have different shapes identified for those particular data points and different colors as well. And those are some of the options that you can use when you start setting up your charts. Here's a pie chart of voters by party. And again, you can use these various types of charts to illustrate your data so that you can get a better idea of what the actual data looks like. So we'll see you next time.